Good evening to everyone. I am Jilalit Kumar. I am going to present a topic line integrals. Let's see the introduction of the line integrals. In ordinary calculus, integration is used to find areas, accumulated quantities over straight intervals. However, in many real-world problems, quantities vary along the curved paths. To handle such situations, we use line integrals. A line integrals helps us integrate a function over a curved rather than over a straight line or a region. It is an important concept in multivariable calculus and vector calculus. Let's think of a line integral as adding up values while moving along a curved path. Now let's know the definition of the line integral. A line integral computes the accumulation of a quantity along a curve. It can be written as integral of f of x comma y ds, where c is curved path. F of x comma y is the function which is going to be integrated. ds represents a small piece of arc length along the curve. Let's know the physical interpretation of the line integral. Imagine a wire went into curved shape. If density varies at each point, line integrals help calculate the total mass of wire. Similarly, if a force acts on an object moving along a curved path, line integrals help calculate the work done. Let's know what are the types of line integrals. There are mainly two types of line integrals, which are scalar line integral, which integrates a scalar field over a curve. It is used for calculation of mass of wire and calculation of heat along a path, and also for charge distribution. And the second one is vector line integral, integrates a vector field over a curve, used for calculation of work done by a force, fluid circulation, electromagnetic applications. Here you can see that scalar integral mainly focuses on a field over a curve, and vector line integral focuses on vector field over a curve. So both depend upon various situations according to names, and both integrate a different part of a curve. Let's see the formula of the line integral for a curve x equals to xt, y equals to y of t, where a less than or equals to t less than or equals to b. Then the line integral becomes integration of f of x comma y ds, that equals to integral b to a f of x of t comma y of t mod of r dash t dt, where rt can be represented as a position vector, and r dash t mod of r dash t gives speed along the curve. Let's see an example of a line integral. Let's imagine a curve x comma y equals to x plus y, and curves b x is equals to t, y equals to t square, where 0 less than or equals to t less than or equals to 1. Let's know what are the steps of a line integral. First, we substitute the parametric values, which are x comma y, and we compute the derivative ds and integrate over this limits. Result gives the values of the line integral along the curve. Let's see what are the examples and what are the applications of the line integral. Line integrals are used in many fields for calculating work done by a force. In physics, it helps us to calculate work done by a force field, and in engineering, it helps us to calculate fluid flow analysis, and in electromagnetism, it is used to help and find the field circulation, and in mechanics, it is used to calculate the motion along the curved paths, and in geometry for measuring weighted lengths. Let's know what are the before going to the advantages, let's know what is the work done by the force field. If F is a force vector field, W equals to integral of F dr, where F is equals to force, dr equals to displacement along the path. This formula calculates the work done when an object moves along the curve. Let's know what are the advantages of line integral. Use it for curved paths instead of straight lines. Help solve practical engineering problems essential in vector field analysis. Forms basis for advanced theorems like Green's and Stokes theorem. Let's move to the conclusion. A line integral integrates a function along a curve. It extends the concept of integration to work curved paths. It plays a key role in vector calculus and physics applications. It is widely used in engineering physics and mathematics. Thank you.